This question here is quite deserving of its title as a hard level question. First of all, let's start with our basic exponential equation format that says that if you have a times b to the x, a is the starting amount, b is the way it changes, and x is the number of times. We also are going to use the idea that when you multiply exponents with the same base, you add, and when you take an exponent and raise it to another exponent, you multiply. So both of those are going to come up. So we figured we could just have them ready to roll. So you would think in this situation that the exponential would say it's starting at a, it's being multiplied by a to the fourth, and that's happening x times. Now, this is wrong, but let's just talk about it for a second. If we had a and we multiplied it by a to the fourth, well, this is a to the first, and that would give you a to the fifth. And if you had a to the fifth and you multiplied that by a to the fourth, it would give you a to the ninth. And that's the idea of multiplying by a to the fourth. So that part is okay. The only problem here right now is in this wrong way of laying it out is that if we had f of 1 right now, if we're testing it out, we would have a, and we would have a to the fourth to the 1. And this is telling us that we'd have a times a to the fourth. This is really a to the 1 right here, right? So we should have a to the fifth when x is 1, according to this way of seeing things. So the way to deal with this is to slide it over by 1. If this is wrong, then this is going to be right. The idea of saying that we've got our a, we've got our a to the fourth still, but we're going to raise it to the x minus 1 power. That's sliding our answers up by 1. Let's test that out. We're going to test it out by doing f of 1 right now. F of 1 is going to give you a times a to the fourth to the 1 minus 1 power there. One minus 1 is 0. This whole thing here is to the 0 power. So we end up with a. And that worked out well. So now we have our equation. Our equation is y equals a times a to the fourth to the x minus 1 power. And now we can do our work. We can say what value is going to give us a to the 29th. Now, the whole thing about k, that tends to throw people off. But this verbiage here is basically saying there's some x value that if we plug that value in, the whole thing, the y, comes out to a to the 29th. So what is that x value? So you don't have to worry too much about the letter k itself. You just have to set this equal to a to the 29th and start solving. One easy thing we can do right now is divide both sides by a. And we're going to have to use the opposite of this rule, which says if I have a to the b over a to the c, that's a to the b minus c. So here you've got a to the 29th divided by a to the 1, and that's going to be a to the 28th. So right now we've got a to the 28th equals a to the fourth to the x minus 1. Now what can we do? We can utilize this rule right here, the power of a power rule that says that in this situation, the 4 and the x minus 1 have to be multiplied. And the way to multiply that would be to distribute. So this is going to be 4x minus 4. So a to the 28th equals a to the 4x minus 4. Now, when you have the same bases and the expressions are equal, it only follows that the exponents must also be equal. So right now we're allowed to say that 28 is equal to 4x minus 4. Add 4 to both sides, you get 32 equals 4x. Divide by 4, and you get x equals 8. And that is our answer to this question, 8.